Hi, Melania. So here we have a line labeled DF, and we are asked to find the length. We're asked to find a length of it if E is its midpoint. So here we have the point D, and here we have the point F on our line, and the midpoint of DF is labeled E. And we are asked to find the length of, there we go. We're asked to find the length of EF. And what's important to note here is that because E cuts this line segment between D and F in half, that we could also do this by finding the length of DE, right? These are the same because this point here cuts our line in half, right? DE is going to be the same as EF. And we're going to use that to our advantage. So we know that DE is 15 minus 3x in length. But because E cuts D and F in half, this chunk is equal to this chunk. So we know that 15 minus 3x is equal to x plus 3. And now we want to get x all by itself so it can tell us what number it equals. So we're going to, since this equation is balanced, we're going to add the same number to both sides to keep it balanced. But what that's going to do is that's going to let us cancel out that minus 3x on this side. You see that? So we add 3x to both sides, so we get 15 equals 3x plus x plus 3. And same thing, we're going to subtract 3 from both sides so that it stays balanced, so that we can cancel out that plus 3 there. You see that? So we're going to end up with 12 equals, well, we combine our 3x and our x, and we get 4x, which tells us that when we one last time do the same thing to both sides, we get that 3 is equal to x. And if we plug 3 in for x, right, we have that D to E equals 15 minus 3x. Well, if we plug 3 in for x, we get 15 minus 9, which is 6. And if we plug in 3 for x plus 3, we get 3 plus 3, which is also 6. And we would want to make sure that these two numbers are equal, which they are, because E cuts it in half. So we are asked to find EF. We've found that it is 6, and that is your answer.